Hi, my name is Nurul and Amira Muhammad Fazil D2021109992 from Group F. So today I'm going to explain about inverse 3 by 3 matrix by using Algebra method. So this is the example of 3 by 3 matrix, which is we have 3 rows and 3 columns. So to find inverse matrix by using Algebra method, there is 4 steps that we can follow, which is step 1 is find the determinant of A. Step 2 is find the cofactor matrix, which is C. Step 3 is transpose C to obtain adjoint A. Step 4 is substitute determinant of A and adjoint A into the formula, which is the formula is A inverse equal to 1 over determinant of A multiplied by adjoint A. So now let's proceed to our example. The question is find the inverse matrix of A equal to 1, 3, 2, 0, 2, 2, negative 2, negative 1, 0. To solve this question, we can follow the step that we have learned just now, which is step 1 is find the determinant of A. Why we need to find the determinant first? Because we need to check whether the matrix have inverse or not. If the value of determinant is 0, the matrix is a singular matrix, which mean they doesn't have inverse. Now we need to write down our matrix first, which is A equal to 1, 3, 2, 0, 2, 2, negative 2, negative 1, 0. For this step, I will use arrow method to find determinant of matrix A. So now we copy the matrix, then next to it, we copy column 1 and column 2, which is 1, 0, negative 2, 3, 2, negative 1. In this method, we have 3 downward diagonal and 3 upward diagonal. For each diagonal, we need to multiply it, upward and downward. So for the downward, 1, 2, 0 is 0. 3, 2, negative 3 is negative 12. 2, 0, negative 1 is 0. So for the upward is negative 2, 2, 2 is negative 8. Negative 1, 2, 1 is negative 2. 0, 0, 3 is 0. Sum of the downward minus with sum of the upward to find the determinant of A. So determinant of A equal to 0 plus negative 12 plus 0 minus negative 8 plus negative 2 plus 0 equal to negative 12 plus minus negative 10 equal to negative 2. So our determinant of A is equal to negative 2. So now we move to next step, which is find the cofactor matrix. So A equal to 1, 3, 2, 0, 2, 2, negative 2, negative 1, 0. To find cofactor matrix, we need to know 9 minor. Which is have M11 for row 1 and column 1, M12 row 1 column 2, M13 row 1 column 3, M21 row 2 column 1, M22 row 2 column 2, M23 row 2 column 3, and so on. 31 M3 2, M3 3. So we have 9 minor. Then for M11 is row 1, column 1. Row 1, column 1. We take the opposite, which is 2, 2, negative 1, 0. 2, 2, negative 1, 0. Then for M12, which is row 1 and column 2, we take the opposite, which is 0, 2, negative 2, 0. 0, 2, negative 2, 0. Then for N13, which is row 1, column 3, we take the opposite, row 1 and column 3, which is 0, 2, negative 2, negative 1. 0, 2, negative 2, negative 1. For M21, row 2, column 1, we take the opposite, 3, 2, negative 1, 0. Negative 1, 0. For M23, row 2, column 2, so 1, 2, negative 2, 0. Negative 2, 0. For M23, row 2, column 3, we take the opposite, which is 1, 3, negative 2, negative 1. For M31, row 3, column 1, we take the opposite, row 3, column 1, which is 3, 2, 2, 2. 2, 2, 2. For M32, which is row 3, column 2. So 1, 0, 2, 2. So the last one, M33, row 3, column 3, 1, 3, 0, 2. So this is our minor. Then we calculate it as a determinant 2 by 2, which is AD minus BC. Determinant 2 by 2, which is AD minus BC. I hope you guys still remember. So for M11, AD minus BC, AD minus BC, 2, 0, 2, 0 minus 2, 1, 2, negative 1, equal to 2. For M12, 0, AD 0, 0 minus 2, negative 2. Equal to 4. For M13, 0, negative 1, 0 multiply negative 1 minus 2 multiply negative 2, which is 4. Okay, for M21, 3, 0 minus 2 negative 1 equal to 2. For M22, 1, 0 minus 2 negative 2 is 4. For M23, 1 negative 1 minus 3 negative 2 equal to 5. For M31, 3, 2 minus 2, 2 equal to 2. For M32, 1, 2 minus 2, 0 equal to 2. And the last one, M33, 1, 2 minus 3, 0 equal to 2. To make it cofactor, we need to multiply a minor with its corresponding sign, which is positive, negative, positive, negative, positive, negative, positive, negative, positive. So let's multiply it to get cofactor matrix. So C equal to positive multiply with 2 is 2, negative multiply 4 is negative 4, positive multiply 4 is 4, negative multiply 2 is negative 2, positive multiply 4 is 4, negative multiply 5 is negative 5, positive multiply 2 is 2, negative multiply 2 is negative 2, positive multiply 2 is 2. So this is the cofactor. So now we move to our step 3, which is transpose cofactor. As we know, C transpose is equal to adjoint A. To get C transpose, all rows become column and all columns become rows. So now let we write down our cofactor matrix just now. C equal to 2, negative 4, 4, negative 2, 4, negative 5, 2, negative 2, 2. So let's we transpose it. First row will be first column. First row will be first column. So 2, negative 4, 4. Second row will be second column. Negative 2, 4, negative 5. Third row will be third column, which is 2, negative 2, 2. Next, let's we proceed to our last step, which is substitute into the formula. The formula of inverse matrix is A inverse equal to 1 over determinant of A multiplied by adjoint A. So our determinant of A is negative 2 and adjoint A is equal to 2, negative 2, 2, negative 4, 4, negative 2, 4, negative 5, 2. So this is our determinant of A and adjoint A. We substitute it into the formula. So A inverse equal to 1 over negative 2 multiplied by adjoint A. So we multiply it as standard operation, which is we get negative 1, 1, negative 1, 2, negative 2, 1, negative 2, 5 over 2, negative 1. So this is our inverse of matrix A. Next, to check whether the inverse is correct or not, we can multiply matrix and its inverse. Then we'll get identity matrix. It means the matrix and its inverse has relation. So our matrix A is 1, 3, 2, 0, 2, 2, negative 2, negative 1, 0. And its inverse is negative 1, 1, negative 1, 2, negative 2, 1, negative 2, 5 over 2, negative 1 equal to. First, we calculate for row 1, column 1, row 1, column 2, and row 1, column 3. For row 1, column 1 is 1, negative 1 plus 3, 2 plus 2, negative 2. For row 1, column 2 is 1, 1 plus 3, negative 2 plus 2, 5 over 2. Okay, for row 1, column 3 is 1, negative 1 plus 3, 1 plus 2, negative 1. Next, for row 2 and column 1, row 2, column 1, column 2 and column 3, row 1, column 1, row 2, column 1 is 0, negative 1 plus 2, 2 plus 2, negative 2. Next, row 2, column 2, 0, 1 plus 2, negative 2 plus 2, 5 over 2. Next, row 2 and column 3 is 0, negative 1 plus 2, 1 plus 2, negative 1. Next, row 3 and column 1, column 2 and column 3. For row 1 and column, row 3 and column 1 is negative 2, negative 1 plus negative 1, 2 plus 0, negative 2. Row 3, column 2 is negative 2, 1 plus negative 1, negative 2 plus 0, 5 over 2. Next, for row 3, column 3 is negative 2, negative 1 plus negative 1, 1 plus 0, negative 1. We get 1, 0, 0, 0, 1, 0, 0, 0, 1. So here we get identity matrix, which is our A inverse is correct. Thank you.